Today we're going to talk about how to analyze the Dune Buggy lab that we have started previously. You'll remember that we were taking data to decide if the Dune Buggy was moving at a constant velocity. So the name of the lab and the purpose of the lab have been done for you, but what you have to do is go through and fill out the procedure. So please make sure that you include a screenshot, or you can draw a picture of the lab with the Dune Buggy and the stopwatch and the meter stick. Because along with the picture, the other thing you'll need to do is write down in words which tools you used and how you used them to collect your data. So you need to say, I looked at the front of the Dune Buggy and I measured it on the meter stick shown on the screen, and I paused the video so that I could match the front end of the meter stick with the time and the position. So explain, how did you get the position? How did you know the time? What were the tools that you were using on the video to record your data? Write that down and include a screenshot. Now, you've already had 5 data points that you've recorded, possibly in a data table. And what I did is I did my data table on the same page as my graph, and that's okay. And then to make a graph, remember, you can use these 3 buttons in the upper corner and then tap paper. And then graph paper is an available option for you so that you can just add a piece of graph paper in as I did. So I'm going to go down and look at the graph that I made. And so the things that are important for you to note are that I labeled the y-axis position in centimeters, and I labeled the x-axis time in seconds. And so what you also need is a title. Most people will forget a title. We don't want that. And so your title is always going to be whatever's on your y-axis versus whatever's on your x-axis. So it's a little confusing that we call position x, but on our y-axis is position, and on our x-axis is time. So this is a position versus time graph for our Dune Buggy. That's the correct title for this graph. Make sure you've put a title on your graph. And then when I made this, I want you to notice that I tried to spread it out on my screen as much as I could. Since my biggest time was 4 seconds, I tried to have 4 be as far to the right as possible. And since my biggest position was 117, I made sure my graph included 117, but that it spread up to it as high as I could. So I actually counted. There were 22 boxes here. So I took 117 and I said, oh, that's about 120. And I divided it by 22 boxes, and I thought, well, I can make every box worth 6, but that's going to be a little hard for me. I'd rather make every box worth 5. That's going to fill up my available space really nicely so that I can fill my grid. So I made all of my boxes worth the same amount. You make sure all of your boxes are worth the same amount. And they don't have any breaks in your graph either. Like that the first box is worth 20 and then all the rest of them are worth 5. We don't want that. So once I have my data points plotted, I went through and I found where each one was, and I made them in a different color. The red are my data points. Then I drew a best fit line. And what I wanted to note for you guys is that even though I had a data point that was at 0, 0, I didn't force my line to go through 0, 0. Instead, when I found my line, I just picked a different color. And I said, okay, let's get as close to all my data as possible. Let's drag it straight. And let's see, where can I hit as many data points as possible, but if I have to miss some, I'll miss a little bit above and a little bit below. And so notice, it doesn't have to go through 0, 0 to make that work, and that there's a little bit of flexibility in your best fit line. I know you're used to using linear regression, but for the AP test, they want you to mark up the graph this way by hand to get some extra information out of it. So the purple one was what I went with as my best fit line. And so once you have a nice, smooth one line with your data all put onto the graph the right way, you can start to analyze it. What we're going to do is we're going to try to find the slope of the line. And the slope of the line is found by finding your change in y over your change in x. And so what that really is y2 minus y1 over x2 minus x1. That means I need to find 2 ordered pairs. Something really important is that you may not use data. Do not use data to find slope. We collect the data to make a best fit line, and what we're going to do is say that the line is really telling us about the trend of the data, that some of our points are a little above and some of our points are a little below, and that not each point was perfect, but that purple line is what we're really trying to analyze as to what that dune buggy was really doing. So what I'll do is I'll look for two places where my graph crosses right on the grid hairs, and I'm going to say, okay, at that place and at this place, I see a real nice purple line on two blue lines, and I can look at those and list those ordered pairs. So if I want to list this first ordered pair as x1, comma y1, my x value would be 0.4, and my y value would be 10. And if I come over here, it looks like I am at 4. Maybe not. Okay, it looks like I am at 3.8 as one of my ordered pairs, so I'm going to write them up here for you, x2, comma y2. And so I am at 3.8 and 110. It's okay to mark up your graph this way. In fact, I prefer it. I want you to show me that you did not use data. I want you to show me what the places you chose to use were from your graph so that I know you're analyzing your trend and not a specific data point that may be faulty. All right, so next, what we're going to do is we are going to put those points into this equation. So y2 was 110, y1 was 10, x2 was 3.8, and x1 was 0.4. So that will be 100 divided by 3.4, and I'm going to move that over a little bit for you. Okay, 100 divided by 3.4 is going to give us 29.4. So I'm going to write 29.4 as my slope. Now, you are used to stopping there, but it turns out that in physics class, all number values should have a unit attached to them. So slopes have a unit attached to them. And the way you find your units are this. This 110 and 10, these y values, they had units of centimeters attached to them. So this was 100 centimeters that was traveled, and the x value had units. It was 3.4 seconds that went by. So when you're finding your slope, it's going to be your y units divided by your x units. So that's why it's going to be centimeters per second as the unit for my slope. The next thing I'm going to do is talk to you a little bit about your y-intercept. You would think, oh, it's 0, 0, I know. But if you look at the y-axis, you'll see that this purple line does not cross right at 0, 0. In fact, it's a little below. So this, each box is worth 5, so this would be -5. And so this right here, I'm going to call -2.5. And so I'm going to call my y-intercept -2.5. And again, it's a number, and so it has a unit attached to it. And so as I zoom back out to show you my whole graph, the y-intercept of 2.5 is measured in centimeters. So because it was read from the y-axis, y values are centimeters. So I now have a y-intercept and I have a slope. The reason for finding a slope and a y-intercept are so that I can start writing the equation for my line. We know that in math class, when you have a linear fit, that you can start with the equation y equals mx plus b. And in math, you would have replaced m with 29.4, and you would have replaced b with -2.5. And you would have been done, and your math teacher would be happy. Well, in physics class, we weren't really keeping track of y and x. We were keeping track of the position and time of a dune buggy. So we need to take this equation one step further. So to make what we call our physics equation, we need to do some new things. Instead of y and x, we're going to go up to the graph and say, what was y recording? What was x recording? And then we're going to replace those values with what they stand for. Since y was really a measure of the position of the dune buggy, I'm going to put an x there. And because x was really a recording of the time, I'm going to put a t there. So I now have x equals 29.4 t minus 2.5. This is so much better. Now I can plug in any value for time and end up with a position. Or I can plug on any position and solve for a time. It's still just missing one thing, and that's this idea that, again, all number values need units. And so the units that we're going to use are going to be the units we talked about earlier, that our slope had units of centimeters per second. So we're going to put centimeters per second here. And our y-intercept had units of centimeters. Now I know I need to put my time in seconds, and my position is going to come out in centimeters. And so this is now a finalized, beautiful physics equation that you can use to analyze your questions below. After how many seconds would you be at this position? You can now plug in a value for t and receive a value for x out of your physics equation.